Hello students. So now I am doing class for class 12 science. The topic is inverse of a matrix. So in the last class also we were doing problems on how to find out inverse of a given matrix. So this is the continuation class, right? So we are doing the same exercise, that is exercise 3. The section is each question carries 5 marks. The page number is 214. As you know that we were doing page number 214 in the last class also. So let us continue that one. Okay. So question number 1 is find the adjoint and inverse of each of the following matrices. That is, this is number 2 of question number 1. We did question number 1 of 1 in the last online class. So now we'll do question number 2 of number 1. It is given that the given matrix A is equal to second order matrix 3, 4, 1, 2. You have to find out the adjoint and inverse of each of the following matrices. त तिमीले लास्ट अनलाइन क्लासमा इन्भर्स कसरी निकाल्छ त्यो पनि सिक्यौ, मैले एउटा प्रब्लम पनि गरेको हो। त तिमीले घरमा त्यसलाई रिभिजन गर्यो होला सायद, हैन? त यो पनि म त्यस्तै पाराले गर्छु। बुझ्यौ? अस्ति लास्ट अनलाइन क्लासमा जुन चाहिँ मेथड हामीले युज गरेका थियौं त्यही मेथड हामी यहाँ पनि युज गर्ने छौं। We'll use the same method that we applied in the last online class also. We'll apply the same method here also. Okay, that is how to find out cofactor. How can you write down the adjoint of a given matrix, and from the adjoint how can you get the inverse of this given matrix. Okay, so in order to get the inverse of the given matrix A, first of all you should know the value of det A. So det A means you have to convert this matrix into determinant and you can expand it. And if det A is equal to 0, A inverse does not exist in that case. I told you the reason in the last online class also. Okay, but if det is not equal to 0, then only A inverse exists, then you can find it. Okay, so let us find out det A. So det A is equal, let us convert it into determinant form, that is 3, 4, 1, 2. Now we can expand it. Therefore, what is det A is equal to 3 2s are 6 minus 4 1s are 4. That means what is the value for det A is equal to 2, which is not equal to 0. That means A inverse exists. Therefore, A inverse exists. That means you can find out A inverse. Okay. Now, in order to get A inverse, you should find out the cofactors of each and every element of the matrix A. That means you have to find out the cofactor of 3, cofactor of 4, cofactor of 1, cofactor of 2. So let us write capital A11. That means cofactor of the element which belongs to row 1 and column 1. That means this is 3. 3 is the element which belongs to both first row and first column, isn't it? That is 3. You have to find out the cofactor of 3. So in a case of cofactor, you have to consider the sign also. So you know how to find out the sign, isn't it? You always take minus 1 whole to the power. Since it is given 1 1, you have to add them this suffix 1 plus 1. Then you have to delete the row and the column through the element 3. This A11 means you have to take the cofactor of this number 3. You have to delete the row and the column through the element 3. That means you forget about the first row and the first column. So what remains? 2 only. So into 2, which is equal to minus 1 whole square into 2. What is the value for A11? Which is equal to, it is minus 1 whole square is plus 1. So 1 into 2 is 2. Okay. Next, let us find out A12. A12 means you have to find out the cofactor of the element which belongs to the first row and the second column. First row and the second column. That means 4. You have to find out the cofactor of which number? 4. Okay. So first of all you write minus 1 whole to the power. You have to consider the sign. So what is the method of finding the sign? Minus 1 whole to the power, 1 and 2 are given, 1 plus 2 into. Now you have to delete the row and the column through that element 4. That means this first row and second column are deleted. What remains? 1. So it is 1, which is equal to minus 1 whole cube into 1, right? So minus 1 whole cube is minus 1 into 1. What is it? Which is equal to minus 1, right? Next, a to 1. That means you have to find out the cofactor of that element which belongs to second row and first column. So which is the element here that belongs to second row and first column? Second row and first column. That means 1. Okay. So you have to get the cofactor of 1. First of all, you have to consider the sign. That is minus 1 whole to the power. What is there in the power? This 2 and 1. That is 2 plus 1. Dot. Now delete the row and the column through the element 1. That means second row and first column are deleted. What remains? 4. So which is equal to, now simplify it. It is minus 1 whole cube into 4. Which is equal to minus 4. Right? So again a to 2. So how can you find out a to 2? What is a to 2 actually? Cofactor of the element belonging to the second row and second column. Which is the element here that belongs to second row and second column? This 2, isn't it? That means you have to find out the cofactor of 2. Is that clear? So how can you find out the cofactor of 2? First of all, you have to consider the sign here also. Minus 1 whole to the power, what will be there? This 2 and 2 is there. That means 2 plus 2. 2 plus 2, right? Now delete the row and the column through the element 2. That means second row and second column are deleted. What remains? 3. So write down into 3. So which is equal to, find it? It is minus 1 whole to the power 4 into 3. Which is equal to, you know that minus 1 whole to the power 4 is always plus 1. And plus 1 into 3 is always plus 3. Usually we don't write plus sign. Okay. So these are the cofactors of each and every element of the matrix A. Now let us write B matrix. Let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors. Whose elements are the cofactors of the elements. Let capital B be the matrix whose elements are the cofactors of the elements of matrix A. Right? So now let us write down the matrix B. So therefore matrix B is equal to, actually it is A11, capital A12. This is A21 and this is A22. Right? Next, therefore, now from this matrix B you can find out the adjoint or adjugate of the matrix A. How can you find it? You have to transpose this matrix B. Transpose of this matrix B is defined as the adjoint or adjugate of A. So adjoint or adjugate is written as ADJ A is equal to B transpose, or ADJ A is equal to, what is B transpose out here? Sorry, you have to put the values here. Okay. So I forgot to put it here actually. So capital B is equal to, what is A11 here? It is 2. What is A12? It is minus 1. What is A21? It is minus 4. And what is A22? It is 3. Right? Is that clear to all of you? So now, what is adjoint of A? Adjoint of A is equal to B transpose. That is ADJ A is equal to, what is B transpose? So in matrix B, you have to change rows into columns and columns into rows. That means this first row becomes the first column out here, 2 minus 1 and minus 4, 3. So I think you have understood it. So this is the adjoint of A. So we have got the adjoint of the given matrix. So this is the answer. So I think you have understood it. And so now, what is to be found out? You have to find out the inverse of the matrix A. So what is the formula? What is the formula to get the inverse of the matrix A? The formula is, you know that A inverse is equal to 1 upon date A into what? Into what? A is A. So what was date A actually? Date A was 2, isn't it? That is not equal to 0. 2 was 2 not equal to 0. So A inverse exists. So therefore A inverse is equal to, this is your half. And then what is the adjoint of A? Just now we got it. 2 minus 4. This is 2 minus 4 and minus 2 minus 4 and minus 1, 3. This is minus 1, 3. Is that clear? So now you can multiply by this minus half. This minus half is the scalar multiplication of that matrix. So you can multiply all these elements by half. Or A inverse is equal to, multiply by half here. So half into 2 is 1. Half into minus 4 is minus 2. Isn't it? Half into 2 is 1. Half into minus 4 is minus 2. You can cancel them. Half into minus 1 is minus half. And half into 3 is, that is your 3 by 2. So this is the answer. The answer. So I think I've understood it. In the last online class also we did this type of problem. So I think you have understood it. Okay. So you can check it also. You can check it at home. A dot A inverse is equal to I. You can check it. Just find out A dot A inverse. If you get I, that is 1001, then this is the correct answer. You can check it. Okay. Now let's do the next problem now. So now we will do next question, number 5 of question number 1. Here also you have to find out the adjoint and inverse of each of the following matrices. That is, question number 5 is, capital A is the given matrix which is equal to A plus IB, C plus ID, minus C plus ID, A minus IB. You know I means I is equal to root over minus 1. You know that from complex number. I is equal to root over minus 1, and you know that I square is always equal to minus 1. I square is equal to minus 1. Okay. So let us find out is inverse of the given matrix A. Okay. So now let us find out date A first. So date A is equal, let us convert it into determinant form. A plus IB, C plus ID, minus C plus ID, and A minus IB. So it is converted into determinant form. So if it is converted into determinant form, you can expand it. You know how to expand this second order determinant. You can cross multiply it. That is A plus IB into A minus IB. Then बीच के सारा है minus. Then what do we write? Let us cross multiply here. That is C plus ID is cross multiplied by minus C plus ID. Okay. So here you can use A plus B into A minus B. What is the formula? A square minus B square. So it is A whole square minus IB whole square. Now from this second factor you can take minus common, isn't it? So minus into minus will be plus, and here you write C plus ID first. Then since this minus is taken common here, so it becomes C minus ID, right? So is equal to A square minus, what is IB whole square? I square B square. Plus here also A plus B into A minus B is A square minus B square. What is A whole square? C whole square minus what is B whole square? ID whole square. So I think I've understood it. Okay. So which is equal to A square minus, what is I square? We just found it. I square is minus 1, isn't it? So it is minus 1 into B square. Then plus C square is there. Plus C square. Then what do you write? Minus ID whole square is minus I square D square. Minus I square d square. Okay, so it is a square plus b square plus c square. Since I square is minus 1, so minus and minus plus d square. But in the question, the value for a square plus b square plus c square plus d square is given, which is equal to 1, right? So which is equal to 1. So it is not equal to 0. That means det A is not equal to 0. Therefore, what exists? A inverse exists. What does exist? A inverse exists. So you can find out the inverse of the given matrix A. Okay. So let us write down the cofactor. So in order to get the inverse of the given matrix, you have to find out the cofactors of each element of the matrix A. Okay. So it is denoted by capital A11. Now you know how to find it, isn't it? A11 means which element? A plus IB. Now you know that. Okay. So I don't have to explain to you now A11. So A11 means you have to take the cofactor A plus IB. So which is equal to, what is the method? Minus 1 over to the power 1 plus 1. Now delete the row and the column through the element. First row and first column are deleted. What remains? A minus IB. Let us write it within bracket. A minus IB, which is equal to, so minus 1 whole square is plus, you know that. So it is only A minus IB. Is that clear? This is the cofactor of A plus IB. Now A12. A12 means which element? C plus ID, you know that. I don't have to explain you again in this case. So A12 means C plus ID. That means you have to take the cofactor of C plus ID now. But you have to consider the sign here also. Minus 1 over to the power 1 plus 2. Now delete the row and the column through this element C plus ID. That means first row and second column are deleted. What remains? This one. Minus C plus ID, which is equal to. Now let us simplify it. What is minus 1 whole cube? Minus. Now multiply this factor minus C plus ID by minus sign. So what do we get? Minus into minus plus C, minus into plus minus ID. This is the cofactor of C plus ID. Is that right? Okay, next. Therefore, A13. Oh, not A13, sorry. It should be A21. That is second row and first column. That means which element is to be considered? That is minus C plus ID. That is the element in the second row and the first column. Second row and first column, this one. So how can you get its cofactor? How can you get the cofactor minus C plus ID? It is minus 1 whole to the power 2 plus 1. Minus 1 whole to the power 2 plus 1, right? And so now, you have to delete the row and the column through this element. That means second row and first column are deleted. What remains? C plus ID. This is your C plus ID, which is equal to, what is minus 1 whole cube? Minus 1 whole cube is always minus. Now it will be minus C minus ID. So C plus ID is multiplied by minus sign. So I think I've understood it. Again you have to get A22, capital A22. So what do you mean by A22? So A22 means element belonging to the second row and the second column. Second row and second row. That is AIB. You have to find out the cofactor of A minus IB. So first of all, consider the sign minus 1 whole to the power 2 plus 2. Minus 1 whole to the power 2 plus 2. Now we have to delete the row and the column through this element. That means second row and second column are deleted. What remains? A plus IB. Within bracket you write A plus IB. So now what is minus 1 whole to the power 4? It is plus 1. What is minus 1 whole to the power 4? It is plus 1, which is equal to A plus IB, which is equal to A plus IB. Okay? So we have determined all the cofactors of the elements of the matrix A. Okay? So now let us write down the matrix B, whose elements are the cofactors of the elements of matrix A. So let capital B be the matrix. Let capital B be the matrix whose elements are the cofactors are the cofactors of the elements of matrix A. Let capital B be the matrix whose elements are the cofactors of the elements of matrix A. Okay, so what is capital B now? It is A11, A12, A21, A22. Now let us put these values now. Or capital B is equal to, what is A11? It is A minus IB. What is A12? It is C minus ID. It is C minus ID. Okay. What is A21? It is minus C minus ID. Minus C minus ID. And what is A22? What is A22? This is your A plus IB. This is your A plus IB. So this is your matrix B. Now you have to find out adjoint of A. So how can we get adjoint of A? Therefore, A is A will be equal to B transpose, which is equal to, what is B transpose? In matrix B, you have to change rows into columns and columns into rows. Now this first column becomes the first row. A minus IB, then minus C, minus ID. This is the new first row. And what is the second row? It is C minus ID and it is A plus IB. So this is the adjoint of the matrix A. So is that understood? Now we have to find out inverse of the matrix A. Okay? So now let us find out the inverse of the matrix A. So how can we find out the inverse of the matrix A? You know the formula. That is, the formula is A inverse is equal to 1 upon det A into what? It is A is A. This is the formula. Right? So A inverse is equal to 1 upon det A was 1, isn't it? We just calculated it. Det A is 1. And what is the adjoint of A? This one. What is the adjoint of A? A minus IB. Let us copy it. A minus IB, then minus C minus ID, minus C minus ID, then this is C minus ID, this is C minus ID, right? Then what? A plus IB. Then it is A plus IB. So 1 by 1 is always 1, you don't have to write it. So therefore this is your A inverse is equal to, what is here? It is A minus IB minus C minus ID. This is C minus ID and this is your A plus IB. So this is your final answer. That is your A inverse. Okay. So I think you have understood this one also. So you can copy it. So we'll do the next problem now. So now we'll do question number 1, number 5. So let us find out the adjoint and inverse of this matrix A, which is third order. That is, 3 rows and 3 columns are given out here. So in the previous theorem we found out the adjoint and inverse of the matrix, which was second order. Now this matrix A is of third order. So let us find out this. Let us find out its adjoint and inverse of the matrix A. So first of all, you have to find out det A, right? So let us find out det A first. You have to convert into determinant form. 1, 2, minus 1. It is 2, 4, 6 and 1, 1, minus 2, right? Let us expand it. So det A is equal to, let us expand it with respect to the first one. You know how to expand it, isn't it? Plus minus plus 1 within bracket. Determine the column to the element. What remains? 4, 6, 1, minus 2. Cross multiply. 4 minus 2 is minus 8. Then 1 into 6, minus 6. Then write down minus 2 within bracket. Delete the row and the column through the element. That means first row and second column are deleted. What it is? 2, 6, 1 minus 2. That is 2 into minus 2, minus 4, minus 6. Right? Then comes plus. Plus minus plus. But plus and minus is minus 1 within bracket. Delete the row and the column through the element minus 1. That means first row and third column are deleted. So it remains 2, 4, 1, 1. That means 2 ones are 2, minus 4 ones are 4. You know how to expand it, isn't it? So is equal to, this is 1 within bracket minus 14, minus 2 within bracket minus 10, minus 1 within bracket, this is minus 2. Which is equal to minus 14, minus to minus plus, 10 2s are 20, minus to minus plus 2. So which is equal, this is 20 plus 2, 22 minus 14 is equal to 8, which is not equal to 0. That means what exists? A inverse exists. So A inverse exists. Okay. Now what is to be done in the next step? We have to find out the cofactor of each element of the matrix A. So how many elements are there? 9 elements. You have to find out the cofactors of all these 9 elements. Okay. So let us find it. So here det A is equal to 8. Let us write it here. It is det A is equal to 8, right? So which is not equal to 0. That means A inverse exists. So let us find out A11. You know A11? A11 means element belonging to first row and first column. First row and first column, that is 1. You have to get the cofactor of 1. Okay. So what is the method? Minus 1 whole to the power 1 plus 1. You have to consider the sign. Now delete the row and the column through the element 1. First row and first column are deleted. What remains? 4, 6, 1 minus 2. You have to write here the second order determinant, right? So it is 4, 6, then 1 minus 2. Let us simplify it. What is minus 1 whole square? It is plus 1. So now you can cross multiply it here. You can expand it, isn't it? So 4 into minus 2, minus 8, minus 6 is equal to minus what? It is minus 8 minus 6 is minus 14. Is that clear? Next we have to find out A12. Let us find out A12. How can you find it? A12? A12 means you have to find out the cofactor of the element belonging to the first row and second column. That means 2. You know that, isn't it? So what is the cofactor of 2 now? How can you get it? Minus 1 whole to the power 1 plus 2. Now delete the row and the column through the element 2. First row and second column are deleted. What remains? 2, 6, 1 minus 2. Okay? 2, 6, 1 minus 2. So which is equal to? Now what is minus 1 whole cube? You know that minus 1, isn't it? So let us write minus 1 and within bracket you write. This is minus 4 minus 6, which is equal to, how much is that? This is your 10. Is that clear? So this is 10. So now next A13. What is A13? Cofactor of the element belonging to the first row and third column. First row and third column. That is minus 1. You have to find out the cofactor of minus 1, right? Let us consider the sign. How can you consider the sign? Minus 1 whole to the power 1 plus 3. And then delete the row and the column through the element minus 1. What do we get? 2, 4, 1, 1. Isn't it? 2, 4, 1, 1. Which is equal to? Now you know that minus 1 whole to the power 4 is there. So it is even number. So minus 1 whole to the power 4 even number is always plus 1. So plus 1, plus usually we don't write it, isn't it? So 2 minus 4. So it is 2 ones are 2 minus 4, which is equal to, what is here? This is minus 2. So I think you have understood it, this one also. Okay. So next is your A21. What do you mean by A21? What is A21? Cofactor of the element belonging to the second row and first column. Second row and first column. That means 2. You have to find out the cofactor of 2. So let us consider the sign. Minus 1 whole to the power. This is 2 plus 1. Now delete the row and the column through that element 2. That means second row and first column are deleted. 2 minus 1, 1 minus 2. 2 minus 1, then 1 minus 2. Is that clear? 1 minus 2, which is equal to, let us simplify it. What is minus 1 whole cube? Minus 1. This is your minus 1 within bracket cross multiply. Minus 4. 2 into minus 2, minus 4, then plus 1. So which is equal to, if you simplify it, you will get only 3. Is that clear? Next, A22. So A22 means cofactor of the element belonging to the second row and second column. Second row and second column. That means 4. You have to find out the cofactor of 4 now. Let us consider the sign. Minus 1 whole to the power 2 plus 2. Right? Now delete the row and the column through this element 4. That means second row and second column are deleted. What remains? 1 minus 1, 1 minus 2. 1 minus 1, 1 minus 2, which is equal to. Now what is minus 1 whole to the power this 4? Even number plus, right? Let us cross multiply it. Minus 2 plus 1 is equal to minus 1. So is that understood now? So it's correct. Okay. Next, A23. What do you mean by A23? Cofactor of the element belonging to second row and third column. Second row and third column. That is 6. Right? Now consider the sign. Minus 1 whole to the power 2 plus 3. Now delete the row and the column through the element 6. That means second row and third column are deleted. What remains? 1, 2, 1, 1. It is 1, 2, 1, 1, which is equal to, what is minus 1 whole to the power 5? Is it plus or minus? It is minus. So this is minus. Within bracket, 1 ones are 1 minus 2, which is equal to plus 1. Because 1 minus 2 is minus 1, so minus 1 minus plus 1. Is that clear? So this is your A23. The next one is, what is to be calculated now? A31. What is meant by A31? Cofactor of the element belonging to the third row and first column. Cofactor of the element belonging to the third row and first column. Element belonging to the third row and first column. That is 1. You have to get the cofactor of 1. Okay. Let us consider the sign. Minus 1 whole to the power. What will be there? 3 1 is there. 3 plus 1. Ln add 3 plus 1. Now we have to delete the row and the column through the element 1. That means third row and first column are deleted. What remains? 2 minus 1, 4, 6. 2 minus 1, it is 4, 6. Which is equal to, what is minus 1 whole to the power 4? Even number plus 2 6 are 12 minus 2 minus plus 4. Which is equal to, how much is it? It is 16. You know that. Right? Next one is A32. So let us find out A32 now. So what is the meaning of A32? Cofactor A32 means that you have to find out the cofactor of, the element belonging to the third row and second column. Third row is this one and second column is this one. That means 1. This one. Okay. Let us consider the sign again. Minus 1 whole to the power. How can you consider the sign? Minus 1 whole to the power. 3 plus 2, right? This is 3 plus 2. Now delete the row and the column through the element 1. That means third row and second column are deleted. What remains? 1 minus 1, 2, 6. 1 minus 1, 2, 6. Which is equal to, next, calculate it. Minus 1 whole to the power 5 is always minus 1 and within bracket it is 6 minus 2 minus plus 2, which is equal to minus 8. So we are getting it as minus 8. That is A32. Next, A33. So what is meant by A33? Cofactor of the element belonging to the third row and third column. So which is the element here belonging to the third row and third column? Third row and third column is minus 2. That means you have to find out the cofactor of minus 2. But first of all, consider the sign. Okay, you have to find out the cofactor of this minus 2, right? So consider the sign -1 whole to the power 3 plus 3. Now you have to delete the row and the column through the element -2, right? So third row and third column are deleted. What remains? 1, 2, 2, 4. 1, 2, 2, 4. So I think you have understood it. Okay? So which is equal to, now how much is it? -1 whole to the power 6 is 1 always. You don't have to write it. So this is 1 4s are 4 minus 4. Right? 1 4s are 4 minus 4, which is equal to, what is here? It is 0. So I think you have understood it. Now we have to write, let B be the matrix. Let B be the matrix. Let us write it here, okay? Let us write A11 is, how much did we get? Let us write it in the rough. A11, how much is it? -14. A12, how much is that? I'm just writing it here because I have dropped that one. A12 is 10. We need it. So that's why I'm writing here. A11 is -14. A12 is 10 and A13 is minus. A13 is what? It is -2. So let us write here. Okay. So data is also 8. So here you will write. Here you will write. Let B be the matrix. Let B be the matrix. Let B be the matrix. Let us write it. Let B be the matrix whose elements. Let B be the matrix whose elements. Let B be the matrix. Let B be the matrix whose elements are the cofactors. Whose elements are the, let B be the matrix whose elements are the cofactors of the elements. Let B be the matrix whose elements are the cofactors of the elements of matrix A. Of the elements of matrix E. Okay. So next, let us write B matrix. What is B matrix here? You have to write it serially. A11, A12, A13. Then this is A21, A22, A23. Then comes A31, A32 and A33. Alright. So I have to drop it also. Let us write A21 here. What was A21? It was 3. And what was that A22? It is -1. Is that correct? A21 is 3 and A22 is -1. So next, let us write down its value. What was A11? It is -14. It is -14, right? A11. What is A12? What is A12? 10. What is A13? It is -2, right? It's correct. What is A21? 3. A21 is 3. And what is A22? It is -1. And what's about A23? It is 1, right? And what is A31? It is 16. What is A32? It is -8. And last one is A33 is 0. What is A33 here? It is 0. So this is the matrix B whose elements are the cofactors of the elements of matrix A. Okay. So now you have to calculate, or you have to find out the matrix adjoint of A. So therefore A is equal to what? It is defined as B transpose. That is, in matrix B you have to change rows into columns and columns into rows, right? That will give you adjoint of A. So therefore A is equal to, what is B transpose? Now first column becomes the first row. -14, 3, -14, 3, 16 is the first row. What is the second row? 10 minus 1, 10 minus 1 and minus 8, 10 minus 1 and minus 8, and next minus 2, then it is 1 and then it is 0. So this is your adjoint of A. So this is the answer, right? Now we have to find out what? A inverse, isn't it? So therefore A inverse is equal to, what is the formula? 1 upon det A. 1 upon det A into what? It is ADJA, right? So A inverse is equal to, what is 1 upon, what was det A? It was 8, right? And then copy it, adjoint of A, minus 14, 3, 16, 10, minus 1, minus 8, minus 2, 1, 0. This may be the answer. You can keep the answer as it is here, or you can multiply all these elements by the scalar multiplication, that is 1 by 8. That is A inverse is equal to, now multiply by 1 by 8 here, minus 2 7s are 14, 2 4s are 8, isn't it? Minus 14 by 8, that means 7 by 4. 2 7s are 14, 2 4s are 8. Then 3 by 8, then this is 2, right? Then this is 5 by 4, right? 5 by 4, 2 5s are 10, 2 4s are 8. Then minus 1 by 8, it is minus 1 by 8, then minus 1 into 1 by 8, that is minus 1 by 8, then minus 1. This is your minus 1. Next, minus 1/4. This is minus 2 by 8, minus 1/4. So 1 by 8 into 1 is 1 by 8, right? And 0 by 8 is always 0. So this is also the answer. So this is your A inverse. Okay? So you can copy it. Now I will give you the homework. Okay? Now these are your homework, so you can practice it at home. Okay, so you can find out, this is question number 1, find the adjoint. You first find out the adjoint and inverse of the following matrices. That is, number 3 is second order matrix, cos alpha, sin alpha, minus sin alpha, cos alpha. Number 4 is second order matrix, A, B, C, D. And this number 5 is the third order matrix. A is equal to, matrix A is equal to first row 1 2 3, second row 3 minus 2 1, and the third row 4 2 1. Okay, and number 6 is also the third order matrix. You can practice it at home. Okay, first row 2 5 3, second row 3 1 2, and in third row 1 2 minus 1. यो चाहिँ तिमीहरुको होमवर्क हो, अनि प्र्याक्टिस गर्नु, जति प्र्याक्टिस गरे त्यति राम्रो हुन्छ. ठीक छ? त यो चाहिँ तिमीले घरमा गर्नु, बुझ्यौ? अन्त नेक्स्ट क्लासमा चाहिँ म तिमीलाई हाउ टु सल्भ given system of equation with the help of matrix inversion method. Okay, so this much is for today, right? You can copy it.